So switching over to Autodesk Inventor, we have a few things to tip you off on the use of the mold design technology and functionality. One, with the tooling installed onto our system, there's always a great resource that I'm using today, the Mold Design Help File System. You can follow along in the interactive tutorials as I found here. Again, I'll be following these same chapters. The first thing we need to do is make sure our project file is configured to our tutorial files. If you don't already have the tutorial files located in your list, you can simply browse out to it to find the proper project to be working from. With it active, we can now start our first mold design application. In this case, I'm going to select File New. With the File New, I need to find my metric file and my moldassembly.iam. With that found, I can simply open it and get ready to begin the subsequent work we have to do. Now that we've entered our mold design user interface, we have a few different environments we can work with. First thing we need to do is bring up part file we do want to work with inside of Inventor. So in this case, as my ribbon bars have updated, I can now select the first plastic part I will use inside of my design. In this case, I'm looking for a file labeled Mobile Top. I found my Mobile Top IPT, and I simply bring that into the Inventor. In our first topic, we're going to define the mold parameters for orientation and material type for our application. So on our ribbon toolbar, we're going to find our mold layout tab itself. We're already highlighted inside of that tab. The first thing we're going to do, and what you'll find traditionally when working through the mold functionality inside of Inventor, is that we're going to work from a left to right scenario in most cases. So we've brought our part in, now we need to adjust our orientation as needed. Truly what this command does is perform an analysis of the model's surfaces. All the green surfaces have a draft angle between the surface and the z-axis, which is greater than 0 degrees. A blue surface will have a draft angle between the surface and the z-axis, which is less than 0 degrees. So with this defined for us, and we agree to the orientation, we can simply go through and cancel this out. Next, again working left to right, is selecting the material properties to be used for this plastic injection mold. There's a large database that's available for us to choose our proper material specifications. So here I'm looking for SABIC plastics, and also the proper trade name for the given plastic I'm using. With my material and manufacturer selected, I can now achieve more details upon this material by selecting my materials button. Again, recommended processing information, rheological properties, filler properties, the recommended processing. Again, a lot of information can be displayed for us. Again, once we have our material selected, we can go ahead and move on to later in the chapter. So with our orientation selected and adjusted, we are now going to start creating the core and cavity of this model. So what I can do, again, working from left to right, is simply go to my core and cavity functionality. What we'll find is inside of this area, we're going to be able to define the workpiece setting. And with doing that, it gives us our basic setting for the shoe of this mold. We can go ahead and enter in additional parameters if needed. In this case, we'll make a change to the Z total and change it to 50 millimeters. We can see how our box increased on our screen. Now, we're going to move into defining the parting surface of the part itself. Again, within our core and cavity tab, which we're still in, we're going to create our patching surfaces. Again, what you'll find when using this functionality of Inventor, the functionality really does most of the work for you. Some very simple things you do need to go through to ensure proper mold design. In this case, we can see it's generated a list of the surfaces it's patched for me along the way. So in some cases, there are dual surfaces that we need to worry about. In this case, surface 3 and surface 4 are no longer needed. I'll remove those from my model and move on to the next area. After creating our patching surfaces, we also need to indicate the runoff surface. Again, simple enough. Select a Create Runoff Surface and allow the software to do the work. As illustrated on the screen, we'll see directional arrows for the surface runoff. After the workpiece patching surfaces and runoff surfaces have been created, the Generate Core Cavity command is used to split the workpiece into the core and cavity. So on our ribbon toolbar, we're going to look at the Core and Cavity tab, the Parting Design panel, and Generate Core and Cavity. Again, a simple one selection and let the software do the work. With this completed, we now allow the software to do a little bit more of investigation for us. The next possible step when working with this design may be generating the gate location for proper injection. Again, working from our Core and Cavity tab and our Plastic Part panel, we're going to select Gate Location. We're going to zoom into our model to select a proper location for adding in a potential gate location for this part. In this case, it may take years of experience and some good knowledge of understanding proper placement. But don't worry, the software is here to help us. Here I'm just going to select a location on my part and apply that location at the same time. And now I'm done. You do have the ability to choose other locations as necessary when working inside of the file for multiple gates. If I need to edit my gate location, much like working in Standard Inventor, our model browser on the left-hand side will allow us to generate and make changes as needed. I am going to change the value in this gate location to a ratio of 0.5. And now we'll just finish our core and cavity.